perform the following operations and simplify. So we want to do f of x squared minus 2 times f of x plus 6, where f of x is the linear function 3x minus 4. So I'm going to evaluate this guy by replacing everywhere I see an f of x. I'm going to replace f of x with what it equals, right? I'm going to make a substitution, replace all the f of x's with 3x minus 4s. So instead of f of x, I'm going to have 3x minus 4 squared, right? Instead of f of x squared, I have 3x minus 4 squared, minus 2 times 3x minus 4 plus 6. So just everywhere that I saw an f of x, right? Everywhere where I saw an f of x, I replaced that f of x with the thing that it equaled 3x minus 4. And then we just simplify. How do you square 3x minus 4? 3x minus 4 times 3x minus 4, and then you would distribute, right? I do it in my head with this little, doesn't really rhyme, so I don't know why it sticks in there, but I'll tell you what I do. So it's square the first term, square the last term. What do you get when you square negative 4? Positive 16, right? Take the product of the two things. What's 3x times negative 4? Negative 12x, and double it, and you get negative 24x. Square the first, square the last, take the product, and double it. You can also just write it out and do the distributing, but it just saves you a little bit of time. All right, then distribute the negative 2, and we have minus 6x plus 8 plus 6. And then combine your like terms. So we've got 9x squared minus 30x plus 22. Nope, sorry, I forgot the 8. 8 and 6 is 14 plus 30. You were right. All right, everybody okay with this? Okay. All right, finding the domain of a function, right? So remember, domain is just the set of all values that make the function possible, right? So when you have a fraction, what is impossible to have in a fraction? 0 denominator. So let's figure out what will make the denominator 0. How do I solve that? Yeah, I could factor it, or I could use the quadratic formula, right? So if I factor this, I get x minus 3, x plus 1, which means that x would be 3 and negative 1. But those are the values that you cannot plug in here. Those are the values that will make the denominator 0. So the domain is all values except for these, right? All values for x are okay, except these values are not, because the denominator will be 0. Anything but 3 and negative 1. So you would write it as, you could write set builder, the set of all x's such that x does not equal 3 or negative 1. Oops. And if you wanted to write it in interval notation, which is how my math lab will want you to write it, you would start at negative infinity. You start as far left as you can, right? And then where's the first place I'm going to run into a problem? Negative 1. As I'm going from left to right, the first place I hit a problem is negative 1. So I put a negative 1 there and don't include it, because negative 1 is not part of the domain, right? And then you union that with negative 1, again, not included. That's how we skip over the negative 1. To the next place I run into a problem is 3. Don't include it, because it's not part of the domain. And then union that again with 3 to infinity. They both mean the same thing, just different notations. So either of these would be your final answer. If I don't specify, it doesn't matter, but it might say write your answer in interval notation, or it might say write your answer in set builder notation.
Which one's interval?
The interval is the one with the parentheses. on the right. Yep. This one is called set builder. Okay, so that's when you have a fraction. To deal with domain, you have to think about what will make the denominator 0, and you have to exclude those values from the domain. What about square roots? What can you not have? What's not allowed with a square root? Negatives. Okay, so I have to make sure 3x plus 12 is always positive. Can it be 0? Can you take the square root of 0? Yes. So I have to make sure I need 3x plus 12 has to be bigger than or equal to 0 always, right? Whatever's under the square root has to be bigger than or equal to 0. Can't be negative. So then I just solve this. 3x has to be bigger than or equal to negative 12. Divide by 3. And x, do I have to turn the alligator around? No, because I'm dividing by a positive number. So x has to be greater than or equal to negative 4. So in set builder, I would write the set of all x's such that x is bigger than or equal to negative 4, right? Or in interval notation, how would I write that? What's the negative? Start at negative 4. That's the smallest value you can put in. And then you can go until infinity. Should I put square or round on the negative 4? Square. Because it's or equal to. So negative 4 is included. All right. Yep. 9x squared minus 30x plus 30. Yep. 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 The negative 24x and the minus 6x makes minus 30x. And then 16, 8, and 6 makes 30. All right, let's look at the demo. So we can create new functions by combining 2 or more functions through the operations, the standard operations, addition, subtraction, multiplication, division. So you can take the sum of f and g, and there's 2 different notations for expressing f plus g, right? You can write f plus g of x, which just means f of x plus g of x, right? Just means add the 2 things together. F minus g of x just means f of x minus g of x. F times g means f of x times g of x, and f over g means f of x over g of x. Just exactly what you think that they would mean. So quick example. Let's say I have x squared and 1 over x plus 1 as my 2 functions, f and g. I want to find each of the following and their domains. So what about f? What's the domain of f of x? Are there any restrictions on x squared? No. I can square any number in the whole world that I want to, no matter what, positive, negative, 0, I can square it. So there's no restrictions on f. So when I graph the domain of f, it's going to be negative infinity to infinity, right? All real numbers. And when I graph that on this number line, just means shade the whole number line, right? All real numbers. All right, and what about g? What is my domain of g? Can't be negative 1. All x's, set of all x's such that x is not negative 1. So if I was going to try to put that on a number line, I would, on my number line, I'd put negative 1, right? So I'll do the check mark in a different color. Negative 1, right? So I would want to shade every single number on that number line except for negative 1. So I'm going to put an open circle around the negative 1, like to protect it. I do not want to shade that. And then shade everything else. All right, and then the intersection, right? The upside down U was intersection. So the intersection is what these 2 things have in common. What x values do they have in common? It can help to look at the picture, right? Everything but negative 1 they have in common, yeah. So the first one, -1, is part of the domain, and the second one it's not, right? But we only want to list numbers that are in both domains, where there's both purple and pink on the number lines. Okay, so my intersection of those two sets is going to be everything except -1. So it's where the two sets overlap. That's what intersection means. All right, so if I want to do f plus g, that just means add f of x plus g of x. So that would be x squared plus 1 over x plus 1. And if I really wanted to, I could get a common denominator and add those things, but I don't want to. Just circle it and be done. F minus g, x squared minus 1 over x plus 1. Just replacing f and g with the formulas that I gave you. What about f times g? That would be x squared times 1 over x plus 1. And you can do a real quick simplification here. Multiply the tops, multiply the bottoms. My rule of thumb is that if you can simplify it in one step, go ahead and do it. If it's going to take you a page of paper, don't bother. Right. F over g, so that's going to be x squared over 1 over x plus 1. And I can simplify that in one step, right? I could rewrite x squared as x squared over 1 and flip and multiply the fraction in the denominator. So times x plus 1 over 1, and I get x cubed plus x squared. All right, so let's talk about the domain of each of these. F plus g, any restrictions? -1. Yep. Set of all x such that x cannot be -1. There's the domain. How about f minus g? Same thing. How about f times g? Same thing. How about f over g? It's the same thing. Yeah. Yeah, it should. Sometimes you might get tricked after you simplify. It looks like the domain has no restrictions, right? X cubed plus x squared has no restrictions on it. But that's a simplified version of f over g, right? F over g is this thing right here, and it's got an x plus 1 in a denominator, right? So the domain is still the set of all x's such that x cannot equal -1. So the moral of the story here is that when you're adding, subtracting, multiplying, or dividing two functions, the domain is the intersection of the domain of the two functions, always, no matter what the operation. Okay? Yeah. Okay, so that's 4 ways you can combine functions. You can add, subtract, multiply, and divide functions. Now we have one more way, a new way of combining functions. It's when we use the output of one function as the input for another function. So for example, let's say we have a function, we call it the mother function, and you would read that m of p means m of p is the biological mother of person p. And we have a father function, f of p is the biological father of person p. So what do you think, what does the family member m of f of p refer to? The mother of the father of person P. The mother of the father of person P. That's the grandmother, yeah. Mother of the father of person P. And so that would be the paternal grandmother, right? It's a grandmother, right? Your father's mother is your grandmother. And because it's on your father's side, it's called the paternal grandmother. Nana, yeah. Paternal grandmother. So we used the output, right? F of P is its own thing. That means the father of person P, right? So F of P was an output of the father function, and we used that output F of P to mean a new person that was an input into the mother function. Right? So here's how we combine two functions. The composition of function f with g is denoted f little circle, not a dot, but an open little circle g. And it's defined, it means f little circle g of x means f of g of x, right? It means g of x is going to be the new input into the function f. Then the little circle, composed with, yeah, this, you would read this as f composed with g. Yeah. If you want to find the domain of a composite function, x has to be in the domain of g, right? You have to be able to plug x into g, and then everything that you can get out from g has to be able to plug into f. So we'll do an example and it'll get clearer. Okay. It will, I promise. All right, so here's my two functions again, x squared and 1 over x plus 1. If I want to find f composed with g of 3, that means evaluate f of g of 3. So you always work your way from the inside out, right? Because you want to do what's most in parentheses first, work your way inside out. So what is g of 3? That's g of x, yeah. So, yeah. So g of 3, right? G of 3 is actually a fourth. So I'm going to put a little like note, g of 3 is equal to 1 over 3 plus 1, which is a fourth. So I just looked at my g function and I replaced all my x's with 3's and I got a fourth. So instead of f of g of 3, I'm going to replace g of 3 with the number I just figured out that it is. So this is going to be f of 1/4. What is f of 1/4?
An 8.
1/4 squared, which is not an 8th, but a 16th. Yeah, so the function f squares things, so this is 1/16. So that is f of g of 3 is 1/16. So you have one intermediate step when you're doing a composition. Figure out what the inner thing is, and then apply the outer rule. All right, what if we go in the other direction and I wanted to find g composed with f of 3? So this one was f composed with g. Now I want to do g composed with f. So my inner function is now f instead of g. They changed places. F of 3 would be 9, so g of f of 3 is the same thing as g of 9. And then what's g of 9? 1/10. You look at your g function, replace your x's with 9's, and you get 1/10. So is it commutative? Does the order matter? Yeah, the order matters, so it is not commutative. Commutative means you can change the order. Yeah. When I plugged 1/4 into the function f, I said, okay, well, I went up to the rule. The rule for f is that f of x is x squared. Yeah. So 1/4 squared is 1/16.
How did you get 3 plus 1?
How did I get this? Because they asked me to evaluate f of g of 3. So 3 is my input. Yep. Yep. I squared it, yeah. Okay, all right, let me go back. Just do it again. Okay. All right, so if I want to do f of g of 3. F of g of 3. Now, before break, we learned how to evaluate just that thing. right? Just plain old g of 3. Look at the formula for g of x, right? G of x is 1 over x plus 1. So whatever you replace the x with in the parentheses, you replace all of the x's with in the formula. So if I want to know g of 3, I replaced the x in the parentheses with the g with a 3. So you replace all the x's with a 3 in the formula. So this would be 1 over 3 plus 1, which is 1/4. So this is f of g of 3, turns out, is 1/4. Yeah, and then f is the formula that squares things, right? F of x, whatever I put in parentheses here, I have to square. F of x equals x squared. So if I replace this x with a 1/4 in the expression f of x, I replace the x with a 1/4, right? That means I have to replace all the x's in the formula of the 1/4, which means I have to do 1/4 squared, which is 1/16. Joe, is that a little better? Yeah. Okay. Let's go the other way. We'll get a little more practice. So g of f of 3. So again, work from the inside out. We just want f of 3 first, right? Just start with the f of 3. So you look at your f of x function, f of x equals x squared. If you replace the x here with a 3, then you have to replace all your x's with a 3. So what is f of 3? 9. 3 squared, which is 9. Yeah. So I have to do g of 9, right? I'm just replacing that f of 3 with a 9. And then for g of 9, you look at the g formula. I replaced this x in parentheses with a 9, which means I have to replace all the x's with 9s in the formula. So I get 1 over 9 plus 1, which is 1/10. So part C was yes, the order mattered. I got a different answer when I changed the order. So what if I wanted, not for 3, not just for the number 3. Oh, you know what I usually do that might make this clearer? Let me draw a picture of function machines. So if I wanted to do f of g of 3, composition is like running 2 function machines in succession. So I'm going to run the g machine first and then the f machine. So into the g machine, I'm going to drop a 3. Right? Turn the crank. Right. And the g machine, if I put a 3 in there, is going to give me 1/4. 1/4. Then I take that 1/4, drop it into the f machine, and 1/4 into the f machine gives me 1/16. And if I was going to reverse it, right, you do the f machine first, followed by the g machine. So let's see what happens if I wanted to do this for a general x, not just for the number 3, but for any number. I'm going to have the g machine first. Oh, yeah. Yeah, the order might not matter for some formulas. Yeah. Yeah. For these two, it did. Okay, so a general expression. So if I drop an x into the function g, right, what comes out? What does g do to any number that you put into it? Yeah, it figures out what is 1 over x plus 1. Yeah. And then you're going to take 1 over x plus 1 and you're going to dump it into the f machine. And what does f do to stuff? It squares it. It squares it. So whatever you put into the f machine gets squared. And it doesn't matter how ugly it is, f is the machine that squares stuff. So this is going to be 1 over x plus 1 squared. So that's sort of a pictorial version of what happens. If you want to look at it more algebraically, f of g of x. My formula for g of x was 1 over x plus 1, right? well, actually, let's do it a little bit differently. So the formula for f was x squared. So let me write this. F of x equals x squared, right? So f of g of x, right? If you replace this x with a g of x, that's what changed, right? It used to say x and now it says g of x. Whatever you replaced this x with, you have to replace every x in the formula with, right? So this is going to become g of x squared. But what's the formula for g of x? 1 over x plus 1 squared. So that is the formula, the general formula for f of g of x. You can do it algebraically, or you can draw pictures of function machines. Let's go the other order, g of f of x. All right, so I'll do algebraic first this time, since I did pictures first last time. All right, so this means g of f of x. Okay, what's the formula g of x again? Somebody remind me. 1 over x plus 1. Okay, so in the parentheses after the g, there used to be an x. Now there's an f of x, right? So I replaced the x with an f of x in the parentheses in the left side, which means that in the formula, I have to replace every x with an f of x. So this becomes 1 over f of x plus 1. But what's the formula for f of x? X squared. So this is 1 over x squared plus 1. Yes. Yep. Yep, I just did it in some steps. Yep. What if I draw pictures? So my first machine in this case is going to be f. And then I'm going to take the result and put it into the g machine. So if I put an x into my function machine f, out comes x squared, right? Because f is the squaring stuff machine. So then I'm going to take that x squared and dump it into the g machine. And the g machine does 1 over whatever you put in plus 1. So I'm going to get 1 over, I put in an x squared plus 1. All right. So whichever way you feel more comfortable with, if you want to draw pictures every time, that's fine. If you want to do the algebraic method, that's fine. All right. With finding the domain of G composed with F, here I always draw pictures. Like no matter how many times I've done this, I draw the pictures. So I look at my pictures F and G running in succession and I say, okay, do I have any restrictions on the F machine? Is there anything that would make that machine jam? No, I'm just squaring. Whatever I put in, I'm squaring. Everything's cool. Right? I don't have to put a person on that machine to watch it to make sure it doesn't jam. It will never jam, right? Is there anything that could jam the G machine? What? -1. Okay, so what I have to make sure of is that F can never produce a -1. If the F machine outputs a -1, it's going to get fed into the G machine, which would jam, right? Are there any X values, like at the very start of the assembly line? Is there any X value that would cause F of X to be -1? No, I need to make sure, in this particular instance, I need to make sure that x squared would never equal -1. If it did, then the G machine would jam, right? Because you're going to feed x squared into the G machine, it would jam. But is there any such x value that would make this happen?
No.
No. So this never happens. So my domain is actually all real numbers. I can plug any x I want into F, and it will run through F and run through G. Nothing bad will happen. So in this case, my domain is negative infinity to infinity. Because the G machine is 1 over x plus 1, right? G of x is 1 over x plus 1. Right. You look at each machine separately. Yeah. You got to make sure, because a composition is actually two machines run in succession. Yeah, the final formula is like, let's say I could build a new machine instead of using 2, right? This would be the new machine that would be 1 over x squared plus 1. But it's actually two machines in succession, so you got to make sure neither one jams. F composed with G. You could give it a new name. You could call it H. All right. You guys can get started on your stuff, and I will help.